Hi, this is Na from period 1. We are given a polynomial of a fourth degree, and we are going to find all the zeros. So the first step is to find the possible real rational zeros, and to do this, we will list the factors of negative 35, the leading coefficient, which is positive or negative 1, positive negative 5, positive negative 7, and positive negative 35. We will also find the factors of negative 7, which is the constant, which is positive negative 1, positive negative 7. This is considered the q's, and this is the p's. To find the possible real rational zeros, we will divide p over q, and this gives us positive or negative 1, positive negative 1/5, positive negative 1/7, positive negative 1/35, positive negative 7, and positive negative 7/5. We are also going to use the Descartes rules of sign, and what we're going to do is we can see that this is negative 35, so we're going to bring that negative down. So this is negative, negative, positive, positive, negative, negative, positive, positive, negative, negative. And we are going to see where the sign changes. So we can see that the sign changes from here to here, here to here, here to here, and here to here. There are 4 sign changes, so there's 4 possible positive real zeros. And we also have to consider the fact that there are imaginary numbers, and imaginary numbers are always in pairs, so we can have 4 or 2 or 0 possible positive real zeros. We're going to substitute the x for negative x to find the possible negative real zeros, and because this is a positive degree, this sign is going to remain the same, so it's negative, negative. This is an odd degree, so it's going to change. So this is going to become a negative degree, or a negative sign. This will remain the same, which is negative. This will change into a negative, and this will remain the same, negative. And there are no sign changes, so there are 0 possible negative real zeros. Next, we're going to do synthetic division, and we're going to choose the number negative 1, and we bring down the negative 35, and we multiply it by negative 1, giving us 35. We add that together. That gives us 124. Multiply that by negative 1, gives us negative 124. You add that together. That's negative 234 times negative 1. 63 plus 234 is 297 times negative 1 is negative 297 minus 7 is negative 304. This is not a zero here because we are not given a 0. So let's try a positive number, and let's try 1. So we bring down the negative 35, multiply that by 1, gives us negative 35 plus 89 is 54, times 1 is 54, plus negative 110 is negative 56. Negative 56 times 1 is negative 56, plus 63 is 7. 7 times 1 is 7. Add that to negative 7, and that gives us 0. This is a 0 here. So we're going to try a fraction, and our fraction is 1/7. We are choosing this number from here. So 1/7, we bring down the negative 35. Negative 35 times 1/7 is negative 5. Add that to 54 is 49. Divide that by 7 is 7. Minus 56 is negative 49. Divide that by 7 is negative 7. Plus 7 is 0. This is a 0 here. So these two are our factors. Now we are given a quadratic. We take this number and we add the x's. So it's negative 35x squared plus 49x minus 49. And we can simplify that by taking out a negative 7. And we're going to use the quadratic formula to solve for this. When we plug it in, it gives us this answer, and we can simplify it into 7 plus or minus radical negative 91 over 10. And because this is a imaginary number, we can take out an I, so it's 7 plus or minus I radical 91 over 10. So we know that this number is our zeros, and over here we are going to try to find a common denominator, which is 10. So we have to multiply the top and bottom by 10. So, and then we're going to distribute the negative And this gives us 10x minus 7 minus I radical 91 over 10. And we're going to do the same over here. We're going to distribute the negative. And this gives us 10x minus 7 plus I radical 91 over 10. So this is our factor along with this. So right here we have found all the zeros, which is 1 over 7, 7 minus I radical 91 over 10, 7 plus I radical 91 over 10, and so this is all our zeros. For our complete factorization, it is negative 7. We got the negative 7 when we took it out from the quadratic formula, which is right here. And our factorization is x minus 1 times x minus 1, 7, times x, or 10x minus 7 minus I radical 91 over 10 times 10x minus 7 plus I radical 91 over 10. And this is our answer. Well, I hope you enjoyed my video.
Should I show you?
No,
Oh.
I'm gonna have to cut that out.